Oh, how exactly does a massive 150,000-ton mega container ship climb over a jagged, 26-meter Central American mountain range instead of just sailing through it? It sounds like a physical impossibility, a riddle. But for the entire global economy, the answer is the difference between prosperity and total collapse. Imagine a floating fortress, longer than the Eiffel Tower is tall, literally being lifted into the clouds just to cross a continent. You might ask, why not just dig a hole? Why not carve a simple sea level path straight through the narrow neck of Panama? The answer is simple but brutal. We tried, and it was a massacre. It wasn't just an engineering failure, it was a grueling, high-risk nightmare that claimed the lives of over 20,000 workers. The Earth didn't just resist, it fought back with catastrophic landslides and a landscape that refused to be broken. Digging a clean, level trench across the isthmus was a suicide mission. This forced us into the most complex and high-stakes engineering gamble in human history. To save the world's trade routes, we had to stop fighting the mountain and start outsmarting it. We built a hydraulic staircase of water. But here is the major problem. This isn't just a mechanical marvel. It is the literal windpipe of global supply chains. If this mountain climbing system stops working for even one single day, the global economy doesn't just stutter, it enters a state of total suffocation. Nothing sails, nothing arrives, and the world enters a state of economic cardiac arrest. So, how exactly does the United States military and a team of elite engineers keep this 150,000-ton monster moving uphill without the whole system breaking down? The answer lies in a masterclass of physics and the sheer power of gravity. The answer lies in the most ambitious plumbing project ever conceived, a masterpiece of 20th century engineering that remains undefeated over 100 years later. How do you establish the front line against a mountain? The answer is Phase 1, the lock chambers. Think of the Miraflores and Pedro Miguel locks not just as basins, but as a wolf pack of concrete titans. These aren't just holes in the ground. They are massive, reinforced canyons designed to trap, contain, and then elevate the world's most massive surface vessels. When a Neopanamax ship approaches the entrance, it is entering a kill zone of precision. The walls of the Miraflores locks rise up like 80-foot cliffs on either side. To the captain on the bridge, the margin for error is non-existent. We are talking about vessels over 200 feet long squeezed into a space that offers only inches of clearance on either side. This is the first layer of the wolf pack. The ships are funneled into these chambers, and the moment they are inside, the steel gates, some weighing more than 700 tons, slam shut behind them with a finality that signals there is no turning back. But how exactly do you move 52 million gallons of water into a chamber in less than 8 minutes without using a single mechanical pump? The answer brings us to Phase 2, the invisible bloodstream, also known as gravity flow. This is where Hollywood imagination usually fails. People expect massive, high-powered electric pumps humming beneath the surface, but the reality is much more elegant and much more terrifying. The Panama Canal operates on the same philosophy as a giant, high-altitude battery. That battery is Gatun Lake, a massive man-made reservoir sitting 85 feet above sea level. The process is strictly calculated. Flood, lift, equalize, and advance. Beneath the floor of each lock chamber lies a labyrinth of culverts, tunnels so massive that a full-size locomotive could drive through them with room to spare. When the valves are opened, gravity takes over. The weight of Gatun Lake itself forces the water down through these main culverts, which branch off into hundreds of smaller openings in the floor of the lock. Imagine the sheer force of millions of gallons of water surging upwards simultaneously. The ship doesn't just float. It is surged upward by a hydraulic heart that beats with the weight of an entire lake. Each transit consumes about 52 million gallons of fresh water, all moved by the simple, brutal power of physics. It is silent, it is invisible, and it is absolutely unstoppable. But even with the water rising, how do you keep a ship that weighs 150,000 tons from smashing into the concrete walls as the turbulence of the flooding water takes hold? The answer is Phase 3, the mules. These are the quiet hunters of the canal. Officially called Panama Canal locomotives, they are the literal Luasat or iron mules of the waterway. Positioned on tracks atop the lock walls, these high-traction electric locomotives act as the ship's external nervous system. Usually, a wolf pack of 4 to 8 mules will tether themselves to the ship using high-tension steel cables. But what exactly is their job? They aren't there to provide the forward momentum. The ship's own engines or tugboats handle that. Their job is strictly about precision and stabilization. As the water level in the chamber begins to surge, the ship becomes a giant unmoored cork. The mules must maintain a delicate high-tension balance, pulling and releasing their cables in real time to keep the vessel centered within a narrow 110-foot wide strait. One ship watching the northern approach, one covering the center, and the third hanging back, the mules operate with the same layered patrol box mentality. If the ship veers even a few inches toward the concrete, the mules on the opposite side dig their gears into the rack and pinion tracks and pull with 35,000 pounds of force, neutralizing the threat before a single scrape occurs. Nothing sails, nothing moves, and nothing advances without the total cooperation of these three phases. You have the concrete fortress of the chambers, the hydraulic muscle of Gatun Lake, and the surgical precision of the mules working in a synchronized dance of heavy industry. It is a phalanx of technology designed to be an impenetrable defense against the physical reality of the mountains. To the engineers standing on the lock walls, the system feels invincible. It is the ultimate display of technological superiority, a structure built to last centuries, moving the unmovable with the grace of a clockwork mechanism. Their collective radar coverage, metaphorically speaking, creates an invisible dome of safety over the entire transit. The process is so refined, so strictly calculated, that it creates an illusion of total control. We have spent billions of dollars to ensure that every bolt, every valve, and every steel cable is a masterpiece of reliability. But what happens when the danger isn't something you can see on a blueprint? What happens beneath the surface of this perfect engineering? The answer is a nightmare scenario that nearly snapped the dream of the canal in half before the first ship ever arrived. Because even with a finite but cast sumfam of concrete and steel, the greatest threat to the canal wasn't the weight of the ships or the hardness of the rock. It was something much smaller, much more patient, and far more lethal. Just as the US Navy must account for the silent threat of submarines beneath the waves, the builders of the Panama Canal had to face a biological wolf pack that they never saw coming. As we enter the next phase of this operation, the focus shifts from the strength of the machines to the fragility of the men who run them. After building the perfect mechanical world, we are about to find out what happens when the environment decides to fight back with a strategy that no engineer could calculate. But here is the major problem. After building the perfect mechanical world, we are about to find out what happens when the environment decides to fight back with a strategy that no engineer could calculate. The answer is simple, but it is brutal. For the builders of the Panama Canal, the greatest threat wasn't the hardness of the rock or the weight of the steel. It was a biological wolf pack that they never saw coming. This brings us to phase 3, the counter 3. First, let's look at the virus blade. In this scenario, the enemy wasn't an army or a fleet. It was a mosquito. When the French first attempted to carve a path through Panama in the late 1800s, they brought the finest engineers and the most massive machinery Europe had to offer. To them, the jungle was just a technical obstacle to be cleared. But what happens when your entire workforce starts dying within weeks of arrival? The answer is a massacre. Iran commands a swarm of fast mosquito boats in the Strait of Hormuz, but in the jungles of Panama, the mosquitoes were the literal killers. Yellow fever and malaria operated as a silent, invisible dome of death over the construction sites. To the IRGC, a submarine is invisible, but to the French engineers, the source of the death was equally mysterious. They didn't know it was the mosquitoes. They thought it was miasma or bad air. While they were building hospitals, they were accidentally creating the perfect breeding grounds for the enemy by putting pans of water under bed legs to stop ants. The result? Over 20,000 men buried in the Panamanian soil. It wasn't a swift, clean victory for engineering. It was a grueling, high-risk defeat that forced the French to abandon the project and go bankrupt. The mosquito swarm had successfully defended the isthmus against the most powerful industrial nation of the time. It took the United States years to realize that the opening move of the canal wasn't digging, it was a biological purge. They had to hunt and identify the enemy, detonating the threat not with explosives, but with oil and drainage. They had to treat the entire jungle like a minefield, clearing every stagnant pool of water as if it were a lethal device. But the danger isn't over. Even today, the canal faces a nightmare scenario that no amount of concrete can fix. The answer lies in the Achilles heel of the entire operation: fresh water. Remember the invisible bloodstream of Gatun Lake? Here is where Hollywood imagination fails again. Most people think the Panama Canal is an extension of the ocean. It isn't. It is a bridge made of fresh water. Every single ship that passes through, from a small sailboat to a massive Neopanamax carrier, requires 52 million gallons of fresh water to be flushed out into the sea. This water doesn't come from the ocean. It comes from rainfall gathered in Gatun Lake. But what happens if the rain stops? The answer is a high-stakes naval operation where the enemy is the climate itself. In recent years, severe droughts fueled by El Niño have caused the water levels in Gatun Lake to plummet. Think of this not as a technical glitch, but as a slow-motion blockade of the world's most important shipping lane. When the lake level drops even a few feet, the Thang Mai Nook loses its lift. To counter this, the Panama Canal Authority has to order a lockdown. They slash the number of daily transits and impose strict draft restrictions. This means the massive ships, those floating fortresses, forced to carry less cargo so they sit higher in the water. If they don't, they risk snapping their keel in half on the seafloor of the canal. How does this look in reality? The answer is a natural blockade. Imagine 24 massive cargo ships carrying billions of dollars in electronics, energy, and food sitting dead in the water outside the canal's entrance. They are widely cocktail dispersed to make a targeting nightmare? No, they are bunched together in a massive parking lot in the Pacific Ocean, waiting weeks for a turn to cross. To the shipping companies, this is the most complex, grueling, and high-risk logistical operation since World War II. The psychological impact of this signature war alone is a massive deterrent to global trade. It creates a knife at the throat situation for the United States. Why? Because 40% of all U.S. container traffic passes through this narrow 50-mile strip of water. If Panama dries up, the ports in New York, Savannah, and Houston enter a state of total suffocation. Imagine a billion-dollar fleet sitting helpless because of a lack of rain. It creates a deadly trick, the sea-skimming kill of the economy. While the U.S. Navy can launch fast-attack Apache helicopters to chase down swarm boats, what do you launch against a drought? Who does the Air Force call when the lake is empty? The answer is nobody. This creates a terrifying opposition. On one side, you have the Independence-class littoral combat ships and the Arleigh Burke destroyers protecting the freedom of navigation. On the other side, you have a 150,000-ton cargo ship that is dead in the water because it is too heavy for the shrinking canal. One ship watching the northern approach, one covering the deep channel, but nothing moves. The sheer force of the sledgehammer that is climate change is now threatening the wolf pack of engineering we spent a century perfecting. It is a strictly calculated nightmare. Detect the falling water levels, localize the crisis, classify the economic damage, and try to neutralize the fallout. But at the end of the day, the ultimate countermeasure isn't defense, it's offense. The canal authorities are now looking at multi-billion-dollar projects to find new water sources or build even more massive reservoirs. But even with all our surveillance drones monitoring the environment in real time, the question remains, can we truly control the choke point? If a mosquito could stop the French and a drought can stop the Americans, is the Panama Canal truly an invincible phalanx? Or is it just a patient, high-lethal device waiting for the right moment to fail? As we move toward the final phase, we have to ask, what is the ultimate strategy to address this escalating situation? How do we ensure that this Thang Mai Nook never stops moving? The answer is simple, but it requires a total reimagining of how we fight for the world's shipping lanes. But at the end of the day, the ultimate countermeasure against a drying planet isn't just waiting for rain, it is offense. To neutralize the risk of a total economic shutdown, we launched a multi-billion-dollar preemptive strike, the Neopanamax expansion. This isn't just a bigger hole, it's a smarter one. Engineers dropped massive rolling gates into hardened lock sites and installed a revolutionary smart water-saving system. These basins don't just move water, they recycle 60% of it for the next transit, clawing back every drop from the thirst of the earth. This is the ultimate phalanx of maritime trade. Think of the scale. We are talking about an armada of steel and concrete that facilitates the movement of over $270 billion in goods every single year. Thousands of ships pay the toll for this privilege, but the true value is the invisible dome of stability it provides to every supermarket shelf in America. Nothing sails between the Atlantic and the Pacific without acknowledging the dominance of this 50-mile strip. It is the ultimate anchor of global logistics. Even when the environment throws a sledgehammer at the system, the answer remains rooted in the sheer force of human ingenuity. We make original videos from scratch, and just like this canal, every frame is calculated with purpose. In this high-stakes game, there is no room for error. We have proven that even the most grueling, high-risk operations can be mastered through technology. We have conquered the mountain, the mosquito, and now we are outsmarting the drought. Because at the end of the day, the legacy of Panama isn't about the rock we moved or the parasites we fought. In the battle between man and geography, the ultimate weapon is not violence, but absolute precision calculation.